Okay, hello everyone. Welcome to NASA's Break the Ice Lunar Challenge informational webinar, and thanks for joining. This webinar is being recorded. I'm Naveen Vecha, Challenge Manager for Break the Ice Lunar Challenge. I support NASA's Centennial Challenges program through Jacob Space Exploration Group. Today we are going to share a lot of information about this challenge. We hope you will compete in this challenge and help achieve NASA's goal of sustainable space exploration. Next chart, please. Here is today's agenda. I will introduce our team and we will go over some housekeeping items. We'll then provide an overview of the Centennial Challenges program. We'll talk about NASA's roadmap as related to this challenge and why we are doing this challenge. We'll provide an overview of the challenge and get into the further details of the challenge, including the challenge mission scenario, phase 1 submission elements, judging criteria, registration and eligibility requirements. We will take you on a tour of the challenge website. We will then take some questions from you and wrap up by providing some next steps to participate in the challenge. Next chart. Here is our team. Monsi Roman is the program manager for the NASA's Centennial Challenges program. She has been leading this program since 2015. Before that, she worked as a chief microbiologist for the International Space Station's Environmental Control and Life Support System. You already have heard about me. I'm Naveen Vecha, Challenge Manager for this challenge. And we have Pete Carato, is a consulting engineer and lifetime fellow emeritus at Bechtel. He worked as a senior technical specialist at the Bechtel Corporation for nearly 4 decades. He's a subject matter expert in civil and structural engineering and has supported major projects in different industry sectors, including solar, nuclear, mining, and materials. Pete helped in the design and formulation of this challenge. John Vickers is the NASA principal technologist in the area of advanced manufacturing. As a principal technologist, he leads the nationwide NASA team to develop advanced manufacturing technology strategies to achieve the goals of NASA's mission. He's a champion of this challenge and provided guidance for the challenge goals. Jerry Sanders is the lead for NASA's In-Space Resource Utilization ISRU capability leadership team. He has worked in the area of ISRU for over 25 years. He has led multiple strategic plans, architecture studies, development projects, and analog field tests for ISRU advancement. Jerry provided critical inputs for the challenge formulation. And Adam Caridas is the Chief of Staff at Ensemble. Ensemble has expertise in supporting open innovation, digital transformation, marketing, and commercialization. Centennial Challenges program chose Ensemble to help with the promotion and administration of this challenge. With that, I'm going to pass it over to Adam.
Great, thanks so much, Naveen. Really appreciate the warm welcome. And as you can see, we are joined by a very accomplished and diverse group of panelists. Just moving into the webinar instructions and overall overview of how this event will take place. The panelists that you see here will be speaking with regards to various slides in which they have their expertise. We will have a Q&A at the end, and you as an attendee can ask questions in the Q&A feature that you have in your Zoom taskbar. We will be reviewing and moderating the questions throughout the event. You can ask them at any time. We will be receiving all of them, and we will be addressing them at the end, and will be answered by one of us on the panel who might be best suited to address those specific questions. I will like to add that we will not be answering any questions related to solutions or ideas that pertain to this challenge. The goal of this event is to prepare you and equip you with all the knowledge and information that you need to succeed in the challenge. However, we cannot provide any feedback or insight into specific solutions and technologies. As Naveen mentioned, this webinar is being recorded, and we will be sharing it afterwards, along with these slides. They'll be available not only on the breaktheicechallenge.com, which is the challenge website that I'm sure all of you have visited and are familiar with. They will also be posted on our YouTube channel. And I'll be sure to reach out to everyone after this event with information as to how to obtain the recording along with the slides. And without further ado, I would like to introduce Mansi to give an introduction to the Centennial Challenges program.
Good afternoon, everybody. Can you hear me?
Yes, Monsi.
Okay. So it is my pleasure to give you all an overview of what Centennial Challenges program is and who we are and how we fit into this and why we're interested in having you join us. So next chart, please. So first of all, we are a team of incredibly smart people, not me, but my team is just amazing. So it includes Naveen and everybody that you're going to hear from today and others that make this work. We were the NASA's first prize program, so we are very proud of that. We are established to conduct prize competitions in support of the vision of space exploration, inspired by amazing prize competitions of the past, like the Orteig and Ansari X Prize, and are established by a NASA Prize Authority. So that basically allows us to stimulate innovation in research, technology development, demonstrations, and such. And I invite you to look at our authority if you're interested in more information about that. And the program actually started in 2005. So we have been around for quite some time. Our interest since 2015 has been in correlation between what we can do to make space missions possible, answer technology gaps that we have. But at the same time, we are very interested in also looking at how those technologies can help Earth applications. So and we are very interested in gathering information from out of discipline people, like hopefully a lot of you are. So not people not related with the aerospace technologies right now would be amazing in providing inputs that we might have not thought of. Although we absolutely welcome entries and solutions from people in the aerospace community also. So we're not keeping those out, but we would like to increase the amount of solutions by adding additional people coming from outside of our discipline. So next chart, please. So we are part of a toolbox that NASA has to reach out to the communities and different kinds of communities. So you can see NASA Centennial is on the bottom of that light bulb over there, but there's other ways that NASA reaches out to the communities also. So again, we're just a piece of the puzzle on those. Next chart, please. So over the years, we have found that a lot of our challenges have helped open the doors for the competitors to either have contracts with NASA or grow their businesses or learn about something that helps them continue to do what they have been doing in a better way. So we have opened 21 challenges since 2005. Out of those, in those challenges, we have had about 307 teams, including teams that have gone on to do things like, for example, Maston Technologies, who are part of the Lunar lander effort from NASA right now. Final Frontier, who participated in the astronaut glove competition, currently has a contract with JSE. CubeQuest we have 3 payloads in Artemis 1, that secondary payloads that will be launching when Artemis 1 is launched. And then we have a lot of successes also in our 3D printed hab competition that have come back to NASA or that have done that their companies are doing much better as a result of competing we have awarded over $10.3 million, and we have had 42 states and 24 countries that have been part of our competitions. This one is an international competition, so we're really looking forward to inputs from outside of the US as well as from the US. Next chart, please. So the NASA Centennial Challenge is currently is running 7 competitions, with the Deep Space Food one that should be opening in January. So that one is going to join the other 6 that are currently open. You can see Break the Ice there towards the right. But we also, like I mentioned before, we have a competition related to CubeSats in deep space. We have a competition related to tissues that can help us, tissue engineering that can help us perhaps minimize the needs for organs on Earth. So this is about functioning tissues that can work like some of our major organs. So this is a pretty cool competition that we're completing this in the next few months. So keep an eye on that if you're interested in that. We have a competition related to CO2 conversion, when it's about the capturing of the CO2 and converting it into glucose that can be used as a substrate for doing all kinds of things. Building materials, medicines, vitamins, all kinds of food, all kinds of things. Space robotics, where we're looking at autonomy of space systems that can be used on the surface of Moon or Mars and help us do jobs that perhaps are a little bit more time intensive. What's on the Moon, a challenge that opened in September, and it is about looking at ways of store, distribute, and manage power grids on the surface of the Moon. Absolutely looking also forward to using some of those technologies on Earth to hopefully help move sustainable produce energy to areas that where those sustainable energy productions are not close to. Break the Ice, which you will hear a lot about today, and we're excited to share with you, and Deep Space Food, that is about helping produce food, nutritious food that the astronauts can use in deep space missions. Next chart, please. So we want you to be part of this competition. We really mean it. We want you, and we're going to do anything it's in our hands to help you be part of it. So please be sure to contact us if there's anything we can do to help you, or to provide you information about how you can be benefited by competing. We cannot promise NASA. Obviously, we cannot promise NASA contracts or anything like that. Those are a lot harder to get, but most definitely there's so many things that can benefit each of you if you participate, and we take a lot of time, and we would like to make sure that we give it our best shot to help you understand why, and to see if we can let you participate in this competition, help you participate in the competition. So definitely when we say we want you, we mean it. Next chart, please. And with that, I'm going to pass it to John Vickers. Thank you, and hope to hear from you soon.
Okay, thank you very much, Monty. I want to make sure you can hear me before I start.
I can hear you.
Okay, great. So I want to say that we're really excited to start this Break the Ice challenge. I want to thank Monty and her team. The Centennial Challenge program is such a fantastic program. I've had some experience with the program before, and it's really produced some significant accomplishments. We started this discussion about lunar excavation of icy regolith about a year ago, and in about the February timeframe, we had a really fantastic ideation workshop. We held that at the Space and Rocket Center in Huntsville, Alabama, and had more than 50 truly subject matter experts from government, industry, and academia come in. And at that time, we didn't really know what the specifics of the challenge was going to be, but we knew that we wanted to do something in lunar manufacturing, excavation, and construction. And so the purpose of this workshop was for us to converge on what the real technology gaps were that we were trying to solve. A little bit about terminology. In the role that I have as principal technologist, we're really focused about technology development. And so we're looking at technology gaps. And when we can develop those technologies and infuse them into programs, we establish capabilities. So technology leads to capabilities. And then those capabilities lead to outcomes. And so that outcome in this case is the ability to produce a certain amount of water for us to use for sustainable exploration. So this is, we developed this because it's one of the most critical and important areas for us for sustainable exploration on the surface of the moon. And that's the goal of our Artemis program. So based on these inputs from our NASA team working for more than a year and a lot of input from external SMEs, we group these technology gaps into a category, into these three categories that you see: extreme environments, operations and maintenance and repair. And then from that, we designed the challenge to address a certain set of technology gaps. And so these are the priority technology gaps that will allow us to build these capabilities and achieve these outcomes. So excavation of large quantities of icy regolith. And that's really the most important one, because without excavation of this icy regolith, we have no water and we have no, we won't be able to have that sustainable program. So no excavation, no water, no sustainability. So second, after this excavation, we want to be able to deliver large quantities of water. And in so doing, we need hardware and equipment that's lightweight and energy efficient, and hardware and equipment that's reliable and durable in the extreme environments that that the lunar conditions provide. And so those are, and I can't see the last one on my chart. Those are those conditions are extreme cold and permanent or near permanent darkness. I can see them now. Thank you for that. Vacuum conditions. Dust is a particular problem, a serious problem on the lunar surface, and reduced gravity. So those are the conditions we decided that we must address during this challenge. So next chart, please. And so why we're doing this excavation challenge, and I'm talking at a very high level, and we're going to dig deeper in just a minute, but we're trying to enable NASA's mission of sustainable human space exploration. And water is really the most precious resource that we're going to be able to find on the lunar surface. So that's why it's critically important. We want to leverage expertise, creativity, and combination of emerging fields that we see. This allows for the evaluation of a large amount of alternative approaches and concepts from which our judges can select the best and most promising solution or solutions. It aligns with our NASA technology needs. It complements currently funded work. We really have a cohesive, integrated plan around all of the excavation technology and capabilities. And this is a critical piece of that overall plan. This is relevant to support the presidential executive order signed in this year about exploitation of off-Earth resources. And you can go off and find that yourself. It's easy to find. It increases the opportunities for future NASA collaborations with a new group of experts. And like Monzi said, we've seen these teams come back and perform work for NASA in partnership and through contracts and other mechanisms. It fosters partnerships and multidisciplinary solutions, as competition will encourage collaboration of a broad community of practice. And it's that confluence of partnerships, the multidisciplinary approach and competition and collaboration that really makes the Centennial Challenge such a fantastic program, in my opinion. I think that's my last chart, and I think I'm going to kick it back to Naveen.
All right, thanks, John. By now, I hope you got an understanding on the importance of this challenge and where it fits in overall NASA's mission. I will now provide short overview of the challenge. Next chart. The goal of phase 1 of the challenge is to enable the development of innovative approaches to excavate lunar icy regolith and transport the acquired resources such as water under extreme environmental conditions that exist on the moon's polar regions. We are particularly interested in solutions that maximize water delivery while minimizing the energy usage and launch mass. Phase 1 provides a hypothetical mission scenario about which we will talk in a little bit. Competing teams are asked to design a credible and feasible system architecture that addresses the technology gaps that you saw in the previous slides. The system architecture should also meet certain performance requirements. Challenge timeline is shown at the bottom. Registration for phase 1 opened on November 18th, and here is today's webinar shown on the timeline. Deadline to register and submit solutions is June 18th, 2021. And the timeline will be expanded as we introduce more webinars as and when needed between now and June 18th. We are planning to announce phase 1 winners by mid-August. Next chart. Here is the structure of this challenge. As it presently stands, there will be 2 phases. Phase 1 will focus on the development of system architecture for excavation of icy regolith inside a permanently shadowed region and the delivery of water to a storage plant located outside the PSR at the South Pole. And teams will have 7 months to register and submit ideas starting November 18th. We are not asking the teams for development of hardware in phase 1. We'll go over the submission elements in a little bit. And based on responses to phase 1, we will open phase 2. And the focus of phase 2 will be the design, development, and testing of excavation technologies in lunar-like conditions. More information about phase 2 will be released prior to the opening of the challenge, opening of the phase 2. Next chart. Here is the prize purse distribution. Total prize purse for the challenge is $5 million. Prize purse for phase 1 is $500,000. Phase 2, if opens, will have a prize purse of $4.5 million and will last for 27 months. Our goal is not to go over 3 years, beyond 3 years with this challenge. Price breakdown for phase 1 is shown below, with $125,000 for the first place, $75,000 for the second place, and $50,000 for the third place, and up to 10 runners up with $25,000 for each runner-up. We'll talk about the point distribution in a little bit. Teams may receive a maximum of 300 points. In order to be eligible to receive a prize, a team must meet or exceed a minimum score of 100 points. Next chart. This challenge is a collaborative effort between multiple organizations. Centennial Challenges program leads the challenge design, formulation, and execution, and is also responsible for providing the prize for the prize funds. NASA Marshall Space Flight Center and the Kennedy Space Center are the lead centers for this challenge. Subject matter experts from both these centers are heavily involved in the development and execution of this challenge. There is also some support provided by subject matter experts from NASA Langley Research Center. And as mentioned earlier, Centennial Challenges program chose Ensemble to help with the promotion and administration of this challenge. Before diving deep into the details of the challenge, we would like to show you the challenge promo video. Our communications team did a fantastic job creating this promo. I hope you like it and will help us complete the story. Next chart. You can play the video.
Naveen, I'm having trouble accessing the link. Could we perhaps play it on the website?
Yep.
Okay.
Are you still having trouble, Adam?
I'm playing the video right now. Is it? Are you not able to see it?
No, I don't see it.
How about now?
Yep, I see it now.
Okay.
The audio is off. Still can't hear. Well, it's okay, I guess. Adam, you can switch back to the slides. We're sorry. Can't hear the audio.
Okay. We're back to the presentation.
Yeah, so sorry about the technical problem. So if you are interested in watching the video, if you haven't watched it yet, it is on the website. So please feel free to watch it and share it with your colleagues. With that, I'm going to pass it over to Jerry Sanders, the lead for NASA's ISRU Capability Leadership Team. Jerry?
Okay. So I'm going to briefly talk about the mission scenario before we go on. As we've learned, this challenge will describe a hypothetical mission scenario that's similar to what we think might be a real-world lunar mission. What we've learned over time is that different mining concepts for water can be highly dependent on the location of the water, how far it is away from sunlight or sunlit locations where outpost might be, the concentration of the water, and basically different aspects on the lunar surface can highly change different solutions. So to help bound the challenge and make it more realistic, the next couple of charts will talk about a certain mission scenario. So teams will be asked to design a system architecture that incorporates the excavation of what we'll call icy regolith and be able to deliver that to a unit that will process it and eventually deliver the water to a particular location for processing. So as part of this challenge, we'll provide a detailed background information on the specific location and site for you to consider in the challenge, the environmental conditions, including the temperature, gravity, vacuum, and such, the terrain that you'll have to consider for the excavation and the water delivery. We're going to give you some notional profiles on icy regolith, recognizing that we really don't know for sure what the profile is, but assuming it is along these lines, how would it change the architecture that we're asking you to look at? And provide you some hypothetical NASA assets that your excavator would deliver the regolith to. Next chart. So for this particular study, we're looking at a site near the lunar South Pole, near Shackleton Crater, where we found a location that has a significant amount of sunlight, that box that has the delivery site next to it in the top right or top left-hand corner, next to a permanently shadowed crater that has hints that it could contain icy regolith. And this particular site was chosen by NASA for its own study previously, because the distance between the delivery site and the excavation site didn't seem too out of hand, somewhere on the order of 3 to 5 kilometers. And the terrain between the two was not that, was fairly reasonable for what we thought a rover excavator could handle. So the bulk of the activity will take place in the excavation site, the bottom green box, which is in the permanently shadowed crater. The overall mission scenario will last 365 days, and teams are asked to basically excavate enough icy regolith to extract water and deliver it to that water delivery site, 10,000 kilograms over that year period of time. A little bit more information was provided in what's in the permanently shadowed crater, kind of notionally stating where our water extraction plant would be that you would deliver the material, and the green surrounded black region, which would be your excavation location. So teams will eventually have to take the water from that extraction plant site out to the delivery site on some periodic basis. So that they'll have to consider an architecture for traveling to the excavation site in the PSR, excavating the icy regolith, moving the icy regolith to the extraction plant, and then eventually delivering that water to the delivery site. Teams are given 10 kilowatts of a power plant within the PSR to provide continuous power in that particular mission location. Next chart. Now, teams within the PSR, teams need to be able to understand and consider the environmental conditions. The temperature range at the delivery site, which is primarily in sunlight, but will have occasional periods of darkness, can range from, you know, a high of 200 Kelvin to a low of 50 Kelvin, with basically over 60% of that time of a Earth calendar year being continuous sunlight. Within the PSR, we could see temperatures of somewhere between 40 and 100 Kelvin. The lunar regolith is a very fine grained dust over the entire region. Lunar gravity is approximately 1/6 that of Earth, and the atmospheric pressure they mention here as 10 to the minus 12 torr, so extremely hard vacuum. From an ice profile perspective, we're giving you basically a 3-level profile. The top 20 centimeters of the material in the permanently shattered crater is considered to be desiccated, so there's no water in there. Between 20 centimeters and 100 centimeters, we're assuming the bulk average of water is on the order of about 4% water. And then for those that want to continue to dig or have an extraction device that can reach deeper than a meter, there is the potential for potentially a higher concentration of water. So to a certain extent, we're looking at how teams consider this profile in the overall architecture on trying to meet our goal for a year time. And with that, I think I've covered the overall mission scenario.
So greetings, everyone, and good afternoon. This is Pete Corrado, who will be the head judge for this phase of the competition. If we could go to the next chart. So there'll be 3 items that you'll be asked to submit for judging. And you'll get 1 numerical score that will be the accumulation of your scores for each of these artifacts that you're going to give us. Probably there'll be a breakdown by artifact. So the biggest component of your score is the system architecture. And we're asking you to do this in 25 pages. So you're going to have to be crisp. You're going to have to make your figures nice and tight so you can get a lot of words in. Of the system architecture, we have a general submittal where you'll need to describe all of the hardware needed to complete the mission. This is surface hardware. What do you put on the moon and how do you use it? Actually, the biggest scoring part will be your concept of operations. So we need a lot of detail there on what are you going to do in 365 days? And of course, the environmental analysis that goes along with this to make sure you're able to operate in the harsh lunar environments for a long period of time. So this is a year-long mission, which is a challenge. No one's ever spent a year working on the surface of the moon. Next chart, please. Once you've submitted the mission architecture, we will also be doing a performance analysis on what you've submitted. And what we're looking for, of course, is how much mass do you have to put on the moon? How much water will you deliver? And how much energy is used in the whole operation? We're working on detailed rubrics for scoring this. And I can tell you we're considering a 2-part proposition for the score. One part will be the amount of each of these materials and energy that you predict. And then we will have what we call a credibility factor. And that factor will be based on what you submit in the way of reference material that substantiates your mission architecture, whether it's refereed publications, conference proceedings, actual physical tests, as well as the knowledge and experience of the judging panel. Next slide, please. Then there are 2 other components which score slightly less than your mission architecture. One is the excavation plan. And this is a common tool used in any earth moving operation on the earth, whether you're building an earth-filled dam, an open pit mine, a road, and it illustrates your operations, how the equipment moves, how deep you're digging, where do you dig first, second, third. And this could be either a traditional 2D drawing, or it could be a 3D model. We will be accepting those, and that could be something done in a classical road building software or a 4D construction animation software. Within the rules, there's guidance on the file formats that will be acceptable. Basically, we will accept anything that can be opened with a freely available 3D model viewer. And lastly, but not least, and the two items here I think are the ones that are going to be the real grabbers of public attention, is the mission animation video. This is a 5-minute video showing your mission end to end. Where do I start? And what does it look like a year later? Within the rules, there's various components to the video, 60 seconds of setup, 60 seconds of excavation operation, 60 seconds showing end to end. Those are the minimum required contents and 5 minutes total. Of course, there's other background information you have to submit on intellectual property, legal documents, etc. Next slide, please. There will be what I hope to have a really unique judging panel for this. So we've already worked out the different industry and government sectors that we're going to attract judges from. So there will be, for example, traditional earth-based mining engineers. There will be experts in geotechnical operations. We're going to find ice operations people. There'll be academics as well as NASA folks. We'll get folks from the Corps of Engineers. We will have experts actually in video production as well as 3D modeling activities. So there should be quite really a blue ribbon panel, and we will assign judges in their areas of expertise. So obviously, a video expert is not going to judge the credibility of the impacting tool that you design. And we will have people from heavy construction equipment manufacturing on the judging panel as well. It's also the potential for awarding non-monetary prizes for the team that has the largest credible water mass delivered, the lowest credible energy, and best overall environmental performance and lowest landed mass. Next slide, please. So these are right out of the rules. They're rubrics. So this is the system architecture. There's 200 points awarded here, broken out into two separate ways the judges will look at it. 100 points for what we call general system architecture, and then 100 points based on key performance goals. And this is where credibility factors will come in. Next slide, please. This is your scoring rubric for the excavation plan. Again, we'll be looking at either 2D drawings or 3D models in this area. And you will have, of course, judges who are excavation experts looking at this part of the scoring. And next slide. This is actually the mission animation rubric. It's kind of mislabeled at the top and that it says excavation plan, but this is the scoring rubric for the animation. And we're looking for accuracy in the video. So when you're going and having a close-up of the tool hitting the icy regolith deposit, do you see a realistic animation of the tool and interaction with the icy regolith? So here again, we're going to have video experts as well as 3D modeling experts looking at these. And with that, I think I'm going to hand it over to Adam.
Great, thanks a lot, Pete. I hope that helps illustrate the evaluation process that we're going to undertake after the submission deadline in June. So I'd like to go back and cover some of the nuts and bolts with the challenge With regards to registration and eligibility, you know, there, I'm sure many capable solvers on this webinar, a lot of eager thoughts and a desire to participate. And before we get ahead of ourselves with developing solutions and whatnot, we have to make sure that all the individuals and teams that wish to compete and earn cash prizes are doing so within the rules and eligibility of this challenge. So off the bat, considering the registration, if you have not done so, please register either yourself or your team at breaktheicechallenge.com. You are allowed to participate in phase 2, even if you didn't in phase 1. And that very may well be, be the case with some of you all in terms of where your backgrounds and expertise lies. For eligibility, and once again, this is all covered in the downloadable eligibility requirements document on the website. And as Naveen mentioned earlier, this competition is open for teams and individuals outside of the United States. However, your team must be incorporated in the United States in order to receive cash prizes. Your teams must be of 18 years or older to be eligible for cash prizes. And as I mentioned, international teams can compete, but unless your organization is incorporated in the United States or has a primary place of business in the United States, we unfortunately won't be able to issue any cash prizes to you. So if you are eligible, what do you need to do next? So you need a team leader. In the registration, some individuals and teams have team leaders set already, which is great, but we need to know who those team leaders are, as they will be responsible for a lot of the submissions and whatnot that goes into being approved and hopefully winning cash prizes. If you haven't yet registered, please do so using the URL provided here. Registering, unfortunately, is not just enough to be eligible to compete. I have followed up with some folks who have registered already, and I will continue to do so these next handful of weeks. But please download the eligibility requirements document. It's a downloadable PDF, and it needs to be signed and submitted via email at admin@breaktheicechallenge.com. Some of you have already done so. Like I said, we have a handful of filled out eligibility documents so far. However, I would like to remind you that while the primary eligibility document is required during the screening, there are 3 exhibits that also need to be signed and delivered to us in order to be eligible to receive cash prizes. So please keep that in mind when you are providing this information. Once you have uploaded and provided all of the required legal and eligibility documents, we will then verify your status and we'll let you know that you've been approved and eligible to compete. And then once you've done so, we would encourage you to begin developing your solutions and submitting them between now and June 18th. It seems like a long time. However, having run multiple prize competitions, I would encourage you not to wait until the spring of 2021. The 6-month time period will sneak up on you. And given the multiple submissions and submissions formats that Pete mentioned during the eligibility walk through. There are multiple responsibilities that need to be included in the submission that we will be evaluating. With that being said, that concludes our slides for today. And we would now like to address some of the questions that have been coming through. We've received a lot of really quality questions. We've been gathering them, and we would now like to answer some of them. So our first question comes from an individual asking about the process for I'll just say the question. Please explain the process used by NASA water extraction plant that allows it to produce more water in less time with less energy input, with 10% icy regolith versus 4% icy regolith input at the same time, at the same total input mass per hour. Can one of our subject matter experts handle that question?
Let me take a crack at it, Adam. So this is intended to be a black box that's available to all teams. And part of the black box is based on some studies actually done within Jerry Sanders' group. Jerry has sent me some slides on it, and we coordinated this. But basically, it favors the higher quality ore, if you will. So if you think of what we're extracting from the surface of the moon to be like gold ore or iron ore, this is water ore. So the ore that has higher content of water in it is higher quality. And so it takes less energy to produce water from the high quality ore than it does from the low quality. So part of it is black box, part of it is to encourage teams to try and consider, how do I get that deeper material that's harder to extract? I'd like to remind everybody that teams can propose their own water extraction technology if they don't want to use this NASA provided black box.
Great, thanks, Pete. Second question, with regards to eligibility, that Naveen, I feel like you would be best to answer this. Can a company submit a concept currently under development through an SBIR award?
Yes, we need to get back to you on that. Depends on which kind of SBIR. So we'll provide an update to our FAQs on the website. So please watch for that.
Great, thanks, Naveen. Another question for our subject matter experts. Are solvers constrained to 10 kilowatts, or can we supply more if needed?
So again, this is NASA provided hardware that you can take advantage of. I believe the rules allow you, if you want to bring your own power generation equipment with you, you have to ensure that it's captured in your concept of operation, and it adds to the total landed mass that you'll be judged against.
Great, thank you. Another question for the subject matter experts with regards to the mission scenario. Will solvers be provided with information on the launch conditions, or are those not going to be taken into account?
If you're talking about terrestrial launch conditions, no, we're not accounting for that. Bring what you need. We've given some guidance on the cargo volume available. And again, it's guidance. So if you have another vehicle or better information, please feel free to propose that. But terrestrial launch conditions and landing conditions on the moon are not part of what's being judged.
Great, thank you.
That said, obviously, you might want to look at past hardware that's been developed, because if you come up with some extremely light, paper thin kind of concept, we may not necessarily think it's credible from just a generic, hey, you're right, it has to survive launch and vibrations and things, and ascent gravity, acceleration forces and things like that. So, try to be semi-realistic and obviously the engineering that you perform.
Excellent point, Jerry. So you might have been wondering what goes into the quote credibility factors we'll be using. That's a place where this would show up.
Okay. Naveen, are there any technologies that solvers specifically cannot use in their solutions?
No, we don't have any such restrictions. It's about excavation, so as long as stuff falls into that realm, we are good with it. We don't exclude any.
Excellent. Another question with regards to the mission scenario: will there be a clear map of the terrain, or will solvers just have to use the images that are included in this presentation, along with being presented in the mission scenario section of the challenge website?
It's a great question. As a matter of fact, the challenge team is developing an instructional video that will help teams get familiar with how to find lunar terrain maps. NASA has a site called Moontrek, and we'll actually be going through step-by-step picks and clicks on how to navigate to various locations on the moon, those that are given in the rules, how to zoom in, how to extract topographic data, and even how to export that into various GIS software, geographic information software, so you can create your own topographic maps. So that tutorial video, and I think we're actually going to have a series of those, will be showing up on the challenge website probably before the end of the month.
Excellent. Thank you for that response. Another question related to the power plant. Does the water extraction plant power use come from the NASA 10 kilowatt power plant, leaving 7.5 to 8.6 kilowatts for the rest of the architecture activities?
I think Peter answered that to some extent already in stating that the 10 kilowatts is an asset that NASA will have at the delivery site, with the ability or a cable to deliver up to 4 kilometers away, but that if more power is needed, that the team should consider how to get that power.
Okay, great. Thanks, Jerry. Is the system architecture limited to a single launch, or can multiple launches be used?
Multiple launches are not specifically excluded from the rules. Again, credibility factor, the year-long duration, all of that needs to be considered.
Can we utilize nuclear power?
Sure. Your landed mass for a nuke might be a little high, but go ahead.
So Adam, I think you have one more slide to show. We will answer probably all these questions on any rest of the questions on the FAQs document.
Okay. If there were questions that we didn't get to address, please send them in writing, and we'll do our best to answer all of them. And like Naveen just mentioned, we will be updating the FAQ section in the website to address questions that we feel are appropriate and would help all of you as solvers and challenge participants. Thank you very much for providing all these questions. Unfortunately, we are running short on time and unable to address them all, but we will hope to address them all offline. So please send any questions that you might not have any clarity to right now. So to wrap up this event and to conclude our webinar, as mentioned, please provide the required paperwork and submit your solutions by June 18th. We encourage you to stay connected with us throughout the duration of this challenge. You can stay up to date through the challenge website. There's a section where you can provide your email address for updates if you don't necessarily wish to register and compete. You can also continue to keep tabs on the challenge by following the NASA Centennial Challenge program social media. And as I mentioned, you can always send us an email at admin@breaktheicechallenge.com. This email address is where the eligibility and legal documentation will need to be sent to, but you can also ask general questions that we will do our best to respond to. And like I said, also post on the website as an FAQ. Once again, thank you so much for joining us. I hope you enjoyed the event and were able to take away some meaningful knowledge and information that can support you in competing for this challenge. We really look forward to working with you all these next few months and seeing the really innovative and outside the box solutions that you all come up with. Thanks again.